This video will be covering Module 6.4. We're going to look at scientific notation, and this comes from section 7.8 in your textbook. And the objectives we're going to look at are converting between decimal notation and scientific notation, and being able to multiply and divide in scientific notation. So, in some of the jobs and trades that you might be entering into, whether it's in the allied health and medical career field, looking at very small parts per million, or if you're looking at being able to have millwright and you're looking at very small tolerances, you might end up using scientific notation. Also, if you're into electrical work, such as the example here. And so looking at joules of energy. So there's lots of different applications for scientific notation that you might come across. So scientific notation, the important part is going to remember that when you're using scientific notation, that you are going to use this formula here. P equals 10 to the k power, whereas what's important is P is a number that's less than 10. So it can be 9.99999 or greater than 1, but it can't be 10 and it can't be less than 1. And k up here is an integer, or basically a positive or negative number. So remember that. So it's going to be some number over 1 less than 10 times 10 to the number of some kind that can be positive or negative. So let's go and look at this, what these actually look like, and give you an example here. So if we have the number 3,600,000, then what we would be able to do is turn this into scientific notation by simply moving the decimal so that we know what we've got. So notice that 3.6 to the times 10 to the 6th power is 3.6 times a million, which has 6 zeros, which corresponds with where we're at over here on the power. Same thing for a number that is less than 1, and so really small numbers, greater than 0, less than 1, and so it says that the scientific notation is negative. Remember, it's not a negative number though, it's just meaning that the number the measurement is less than 1, greater than 0. So in this case, it's really small. It's 0.0004, which means 4 times 1/100,000th. 10,000th, 1 to the 10,000th place. And so we got 4 times 1 to the 10,000th place, which gives it to the -4th. If it was 100,000th place, then it would be -5. So sorry, I looked at that really quickly as I was zipping along through the slide here. So converting from scientific notation to decimal form is as simple as really moving those zeros. So in this case, when we have 3.2 times 10 to the 4th, we have 3.2, and we're just going to move this decimal over 4 places. 1, 2, 3, 4, and we're going to put our decimal there, and we're going to fill it in. And so we see that this is 32,000. And if we're going the other way, we do the same thing. 2.7 times 10 to the -3rd means that we're going to take our decimal, and sorry about that, I think it dropped my pen and it added an extra, there we go. Decimal look like a decimal, so I don't want to confuse you, so we're going to go 1, 2, 3 and add the decimal, and that is 0.0027. So that's the way to solve those fairly easily. I like putting the little circles under there for students so that they can see that there's zeros belong there. Remember, it's not moving from the end of the numbers, it's moving from where the decimal was. So let's go ahead then and look at these and see how we can multiply and then divide, knowing what we've learned about scientific notation. And basically what you're going to do is you're just going to regroup the numbers, the p, and then you'll regroup that with the exponents. And so in this case, 26,000 times 3,500,000, we'll go ahead and group the 2.6 and 3.5 after you've converted it into scientific notation, and you're going to regroup the 10 to the 4th and 10 to the 6th, and multiply 2.6 times 3.5 and you get 9.1. Multiply 10 to the 4th and 10 to the 6th and add the exponents just like we were learning in the last video for this module, and you get 9.1 times 10 to the 10th, and that's the way to multiply scientific notation. Division is going to be the same way. You're going to go ahead and convert. So 0.000072, we're going to take that and move that 1, 2, 3, 4, 5, 6 places. And so we'll have 7.2 times 10 to the negative 6th, and we'll move this 1, 2, 3, 4 places, because remember it's got to be greater than 1 and less than 10, and that is negative 9 to the negative 9 times 10 to the negative 4th. And since we are dividing this, that's the operation, then we'll go ahead and group our numbers. 7.2 divided by 9, and 10 to the negative 6 divided by 10 to the negative 4th. 7.2 divided by 9 gives us 0.08. And remember, when you are dividing, you are subtracting, and in this case you're subtracting a negative, which means that you're going to add a positive. And so negative 6 minus a negative 4, or negative 6 plus 4, gives you 10 to the negative 2nd. So let's go ahead and look at an example, what we have here. And in this case, this is a word problem. Go ahead and pause the video and read the problem. Okay, so let's go ahead and figure out what we've got here. It says that energy plant generates 173,500 helostats, and the helostat has a value of 1,340,000 of luminescence. And so to calculate the total luminescence, we're going to multiply the helostats by the luminescence. So we're going to multiply 173,500 times 1,340,000, which is big numbers. So let's go ahead and convert those into scientific notation so we don't blow our calculator up. We know that there's a decimal at the end here, so we're going to go 1, 2, 3, 4, 5. So we end up with 1.735 times 10 to the 5th times, let's see, 1, 2, 3, 4, 5, 6. So 1.34 times 10 to the 6th. And so to be able to multiply those together, we will come down to our calculator and go 1.735 times 1.34 and get 2.32. Now remember, our significant value is only 3 places, so we need to round that 9 to 2.3.25. And if you need to remember significant values, you can go back to Module 3, I believe it is, to look and review significant values. And then go ahead and we've got 10 to the 5th and 10 to the 6th, so times 10 to the 11th. And so that's the total luminescence of the power plant. And this also concludes the last video for this module. Thank you very much.